And we're back. Did you like my witch's cackle? Yeah, witch's cackle. Woo! Woo! Thanks for being here and learning with me. So for problems 1924, find the requested attributes of the polynomial. Do a rough sketch of each polynomial without using a calculator. Whoa! You might have to factor first. So number 19, for example, we're going to factor that. Pause me. You need to remember how to factor. You got to know that for this particular assignment. You got to know how to factor. So what do you think? What are factors of x squared? And then what are factors of 9? This looks like a perfect square to me. How about you? 99. Interesting. No, that's not right. See, you can't just copy me. You got to think about it. What are factors of 9? 3 times 3, good. And then, what do you think the signs have to be? What do the signs have to be? So both negative, because negative times negative is a positive. Way-o. Okay, so what's our degree? Do you remember what our degree is? Oh, karate chop! Huh! You a black belt? Are you the highest degree? So the highest degree is the highest power. So the degree is just 2. And since it's a positive, you have to assume it's positive. There's not a negative there. You have to assume it's a positive x squared. And since it's positive and it's even, right? That's an even number. Then it's going to be up and up. Good. What about our x-intercepts? Indicate bounce or cross at each intercept. Well, the weird part about this one is we have x minus 3 all squared. And since our equation is x minus 3 all squared, we actually know the vertex. Way-o. Plus 0. But we can just talk about the x-intercepts. So there's only going to be one with a multiplicity of 2, which means it's going to bounce, right? So we have x minus 3 equals 0. We add 3 to the other side. Good. And so we have an x-intercept. We have an x-intercept at x equals 3, but it is going to bounce. It's going to bounce. And the reason why it's going to bounce is because of the squared. Right? Because of that 2, it's going to bounce. Way-o. It's going to bounce off the x-axis. That's what it means by bounce. Okay? So then our y-intercept comes from our original equation, standard form. So we go back here to our y-intercept, which is a positive 9. So we have 0, 9 for our y-intercept because of this 9 right here. And then our x-intercept is that x equals 3, y equals 0. So then we're going to bounce at that coordinate. We're going to bounce, which makes sense because that's where the vertex is bouncing off. The x-intercept. So at x equals 3, y equals 0, right here. 3, 0. That's a comma, okay? That's a comma. There you go. Okay, so at 3, 0, so our end behavior is up, up. So it's going to be up, up. We have a y-intercept at 9. And so we're going to come up here. We're going to come down here. So we're going to cross through. We're going to cross through at 9. And then we're going to bounce like that. Yeah, we did it. We got a y-intercept at 9. There's our y-intercept at 9. We have an x-intercept at 3, 0. And it bounced. Why did it bounce? Because it had a multiplicity of 2. And because that was its x-intercept right where the vertex is. Remember the vertex form? Y equals x minus 3 all squared plus 0, which means our HK is 3, 0. So 3, 0 was our vertex as well. So that was just lucky. That doesn't usually happen with these assignments. That was just lucky that it was also the vertex. So lucky, also vertex. So go ahead and give number 20 a try next. Give 20 a try next. Go ahead and pause me. No, you pause me. No, you pause me. So pause me and factor it. Factors of 3 and 5 maybe, hint, hint. So try number 20 on your own now. Pause me, try it. I'm waiting. Pause me, try it. Okay, so hopefully you paused me. So then take a look and see how you did on number 21. Pause me. Try it on your own. There's no point to just copying. You're just going to not do good on the test. Or our Bell quiz coming up in the future. Whoa. Okay, let's see here. So we got, what's our highest degree? Well, we have an x, right? We have an x there. And we also have an x as well. But that x is being squared. It's being squared. And so we do have to distribute that 2 through. And so that's to get our degree. And so x times x squared, of course, is x to the 3rd power. Way-o. So our degree is 3, which is odd. That's important to know. What does that mean about our end behavior? Well, since it's going to be a positive, so it's going to be a positive x to the 3rd power, positive. So positive and odd means you're going to start off low, negative, but finish off positive. And so that's going to be down and then up. What's going to happen there? Down then up. For our end behavior, good. Down then up. And then what are our x-intercepts? Well, we have some x-intercepts going on. So we have x minus 5. And so we set that equal to 0. And we add 5 to the other side. So we get x equals 5. Of course, that's going to be 5, 0 right there. And so the question is that a bounce or a cross? Is that a bounce or a cross through? Well, we go to the multiplicity, and the multiplicity is just a 1. And since our multiplicity is just a 1, you're going to cross through. You're just going to cross through. Way-o, just going to cross through there. Just going to cross through. We're just going to cross through there, okay? Yeah, cross through there. Okay. Now, what about the other one? Well, the other one has, it's got a 2 there. And so 2 means to bounce, right? The x plus 4 all squared. The 2 means you're going to bounce off x axis. So we take x plus 4 and set it equal to 0. We minus 4 to the other side. So we get negative 4. And at negative 4 and negative 4 comma 0, we're going to bounce. So don't forget to bounce right there. Don't forget to bounce. Okay, so now we use our end behavior. Okay, so our end behavior is down here. It's down, and then it's up. Okay? Okay, so here's how we do it. Let's put it all together now. Let's go and put it all together now. You behind the screen, put it all together. Pause me and try it on your own. Do you know what to do? So since the multiplicity of 2 at 4, we're going to bounce a negative 4. We're going to go ahead and bounce. We do have a y-intercept. Technically, if you multiplied it out, it'd be 4 squared is 16 times a negative 5, but didn't really ask for that y-intercept, so it'll just be a big number down there. And so then we'll come down here for the y-intercept, and then we're just going to cross through. And that's good enough for now. That's good enough for now, graphing these. Cool. So if you did want to know what the y-intercept would be, it would be negative 16 times negative 5, which is a huge number. And that's just multiplying the numbers and not the x's. So it would be negative 80, but you don't need to worry about that. Okay, so you try it again with number 22. Now we're on the next page. Way-o. Okay, here's a good one. You try it now, 23. Waiting for you. Mr. Pumpkin Bear is waiting for you. He's saying try on your own. Try on your own. You're not going to get this unless you try on your own. So give it a try. Pause me. Try it on your own. And then push play. See how you did here. Okay, so our degree is 4. Good. It's even, so that's good. Since it's a positive x to the even number, it will be up for the end behavior. Now to find the x-intercepts, ooh, let's find the y-intercept. That's easier. So the y-intercept is just going to be at 36. Did you already get that right at least? Way-o. So up here at 36 is where it's going to cross. Right here at 36 is where it's going to cross. Okay, we're going to try to, you got this. We can do this. Come on, it's just x to the 4th power. So factor tree. So what does x to the 4th power factor into? Not x and x, a little bit bigger. That's right, x squared and x squared. So that factors in x squared and x squared. Good. 9 times 4 is 36. Woo! And 9 plus 4 is 13. Woo! And they both have to be negative. Woo! What does that mean? Uh-oh. So that is actually a difference of squares now. No, it's not a difference of squares. Yeah, it is a difference of squares. So x and x, 2 and 2. And plus and minus. And this one's x and x. And how do you do factor 9 into what? 9 factors into 3 and 3, plus and minus, because they're perfect squares. X squared minus 9, perfect squares. Perfect squares, difference of squares, new bulb. That's it, difference of squares. Okay, so that's a lot of x-intercepts, but they all have 1. 1, 1, 1, 1, 1. So that means that they're all going to cross through. They're all going to cross through. They're all going to cross through. So we have x-intercepts at opposite, -2, and a +2, and -3, and +3. So I just set them all equal to 0, added 3 to the other side, and so we get a +3, and don't forget this one is the opposite sign, it's a -3, and then this one is a +2, and this one is a -2, right? Okay, let's do this. Now use the end behavior to help us as well as the y-intercept. End behavior to help us in y-intercept. So our end behavior, it's positive even powers, so it's going to be up. And so it's going to come down, it's going to cross through the y-intercept, cross through, and cross through. I think my phone's ringing. Hold on 1 second. Pause me. And we're back. So it was like this corn maze thing that we're going to go to and pick up some pumpkins or something. Whoa. Amazing client appreciation event at Green Acres Corn Maze. Yeah, donuts and hot cocoa provided. Woo! So we're just headed down there in a second. But let's finish our video first, right? Let's finish our video. Whoa. Okay, so we were right here at finishing this one. Yeah, so they all cross through. Cross through, cross through, cross through. We also got a y-intercept that came from our function, which was a +36. So that's how I kind of knew, and our end behavior told us to go this way, right? Then cross through, hit our y-intercept, cross through, and then back up to our end behavior, which was up. So that's how we did that. Whoa. So you give that a try with the other ones now. Okay, for which of the following conditions will the sum of integers m and n always be an even integer? That's crazy. Huh. M and n always be an even integer, the sum of integers. Let's see. I'm thinking about it. You think about it too. Think about it. I'm going to pause and think about it. Okay, I had to think about it. Did you ever think about it? Did you ever think about it? So if m is an even integer, well, that's not always true because 4, but What if n is odd? So then like 5, for example, that's 9, and that would be odd. So that doesn't work. And if n is even, just switch it. It still could be the other one's odd, so that doesn't work. M and n are both odd integers. Well, let's see. 1 plus 3, or 7 plus 9. So that's like a 16 and 4. That's looking good so far. That's even, that's even. Yeah. If n is odd, integer and m is even, or if n is an odd integer like 3, and even integer like 6. Oh, so that's 9. Yeah, that doesn't work. So I'm thinking if odd plus odd will always give us an even, as well as even plus even will also give us an even. But they didn't list this one, but they're both correct. But the only one they listed is this one. So the answer is C. Thanks, Mrs. Kohea, for helping me with that. I just want to make sure I got that right, and that's what she showed too. So thanks for watching. Thanks for watching. Ooh, 8% of 60 is 1/5 of what number? 8% of 60 is 1/5 of what number? So do 0.08 of means times 60, right? Get a number, and then that same number is going to be 1.